Namaskar. Channel tule সকলোকে স্বাগতম জনাইছো. If you are a student of chemical science, then this video is just for you. In this video, we will discuss some previous year questions of quantum chemistry, third semester or 3.1 paper con. We will discuss some of the questions. So let's not waste time and start learning. The first question I told you, what is the energy of a photon having wavelength of 1.5 angstrom given h is equal to 6.626 into 10 to the minus 34 joules second. Okay, h minus m Planck's constant. Let me remind you, ekita question agote ahi hoise, so this video will be helpful for you, and these are most probable questions. You can practice this, and I hope this will be helpful for you. ठीक है सर. The question is the energy of a photon having wavelength 1.5 angstrom. ठीक है सर. আমি জানো E is equal to h nu. Energy can be related with Planck's constant. Using this relation, E is equal to h nu, and h nu can be further written as hc by lambda, where lambda is the wavelength of light and c is the velocity of light. So as we have the given wavelength, that is 1.5 angstrom, we can use it directly here. In the we have the unit in joule and here it is in angstrom, so that will be problematic. That is why angstrom 2 will convert into SI unit or simply MKS. Class 12 in 10 plus 2 we have studied about these dimensions, so either it should be CGS centimeter gram second or meter kilogram second. So this is in this convention, and the wavelength is given in not exactly in this angstrom. 1 angstrom is equal to 10 to the power minus 10 meter. Okay, we have 1.5 angstrom, so that would generate 1.5 into 10 to the power minus 10 raised to the power minus 10 meter. So we will use this in this equation. So let's see what we get as a result. So h Planck's constant value 6.626 into 10 to the power minus 34. Let me remind you, jodi unit keita আমি আগতীয়াকৈ simplify কৰি লওঁ, so তেতিয়াহ'লে আমি বাৰ ইয়াতে joule, again velocity of light is 3 into 10 to the power 8 meter per second. এইবোৰ লিখি থাকিব কোনো প্ৰয়োজন নাই. আগতীয়াকৈ you simplify the units and either you convert it into CGS or you use the conventional MKS system. তেতিয়াহ'লে in the final যোনটো আমাৰ answer ওলাব, তাত আমি simply either CGS or MKS use কৰি unit to put কৰিলে we will get the correct answer. ঠিক আছে. So here আমাৰ ইয়াতে দিয়া আছে কিমান আছে 6.6 into 10 to the power minus 34 joule second, and this is the velocity of light 3 into 10 to the power 8 meter second. Again lambda dia ase 1.5 into 10 to the power minus 10 meter. Okay, let me put it 1.5 into 10 raised to the power minus 10 meter. So this will yield simply 13.25 into 10 to the power minus 16 joule. Now if you want me to simplify this, I can simplify it for you. Just a second. So let me change the color of the pen. We can cancel this and this. 3 into 0.5. Okay, so we have joule second here, and here it is per second, so this will be simply cancelled. Again meter and meter is cancelled, so remaining our joule ho jabo. So that joule will be the unit, and if we simplify this we get this answer. তোমালোকে কৰি চাবা and give your response in the comment section. Moving to the next question. Next question is calculate the number of photons emitted per second by 100 watt yellow lamp. Yeah, 100 watt yellow lamp, and the lambda is wavelength here is 560 nanometer. Again nanometer, yes, okay, 1 nanometer is equal to 10 to the power 1 nanometer is equal to 10 to the power minus 9 meter. ঠিক এইটো ঠিক প্ৰথম কোৱেশ্চন এইটো দৰে আমি ইয়াতো একে কৰিম, either in CGS or MKS. আমি MKS লৈ যাম, গতিকে 1 nanometer minus 9 meter, so আমাৰ এটা 560 nanometer দিয়া আছে, গতিকে 560 into 10 to the power minus 9, 560 into 10 to the power minus 9 meter. Okay, 560 into 10 to the power minus 9 meter to আমি simply 5.6 into 10 to the power. So we will move this decimal to 1 and 2 positions to the left hand side. So that is why প্রথমতে ইয়াতে আছিল, গতিকে we will move this from this position, the decimal point position from the decimal from this position to this position, that is 2 digit to the left hand side. গতিকে minus 9 plus 2. So this will give us 5.6 into 10 to the power minus 5.6 into 10 raised to the power minus 7 meter. Okay, everything is sorted out. Now let me clear or dismiss. Okay, the main concept of this question is simply to check whether you know the difference between joule, then watt, what is the relation between watt and joule. So প্ৰথমতে মই কৈ দিছো 1 watt ইয়াতে লিখি দিছো 1 watt is equal to joule, 1 joule per second, it is joule per second, or simply joule second inverse, right? ঠিক আছে, গতিকে joule is the unit of which quantity? Joule is simply the unit of energy, right? So আমি এনার্জি joule ৰে এক্সপ্ৰেছ কৰিব পাৰো, গতিকে আমি এনেকৈ লিখিব পাৰো watt, যেটো আমি ইয়াতে লিখিছো watt is equal to joule per second, গতিকে ইয়াতে আমি লিখিব পাৰো watt is equal to energy per second, right? বা energy second inverse. I like energy second inverse, or simply second inverse বুলি লিখি বেছি ভাল লাগে। Anyway, so আমাৰ watt কিমান দিয়া আছে ইয়াতে 100 watt, yellow lamp, blue lamp, red lamp, that doesn't matter, we just need how much watt is given. So here 100 watt is given, so 100 is equal to আমাক প্ৰশ্নটো সুধিছে যে number of photons emitted per second, right? আমি এইটো পিছলৈ আহিম, প্ৰথমতে এই ৰিলেশ্যনটো এস্টাব্লিশ কৰি লওঁ। So 100 watt is equal to energy second inverse, to energy আমি আকৌ ইয়াতে চাই লৈছো, এইখিনি তুমি গম পাইছো E is equal to h nu, or E is equal to simply h c by lambda, গতিকে h is equal to n h c by lambda. Now n মানে কি ভয় খাবলগীয়া কথা একো নাই, n is simply the number of photons. ইয়াত আমি n ইউজ কৰা নাই because we already know a photon দিয়া আছিল, right? গতিকে n is equal to 1 in this question, কিন্তু ইয়াতে আমাক number of photon উলিয়াব দিছিল, that is why we will have to use this notation n, ঠিক আছে? গতিকে n এইখিনি আমি গম পালো, let me shout it out. Okay, this one is number of photons, then h the Planck's constant, then c is the speed of light, and lambda is nothing but the wavelength আমাক 5.6 into 10 to the power minus 7 meter আমি উলিয়াই লৈছিলো, 560 nanometer দিয়া আছিল, গতিকে ৰিলেশ্যনটো আমাৰ এনেকুৱা হ'ব, গতিকে এইখিনি is equal to number of photons, so simply n, isn't it? 100 তোমালোকৰ চোৱাচোন 100 into 5.6 into 10 to the power 7 meter আমি আগতে উলিয়াই লৈছিলো ইয়াতে, yes, this one 5.6 into 10 to the power minus 7 meter আমি উলিয়াই লৈছিলো, গতিকে okay, joule per second, this one is not joule second, joule per second, এইখিনিৰ পৰা joule and joule cancel out হ'ব, again we have second inverse and second inverse cancel out, and meter will be cancel out, গতিকে remaining will be n number of photons per second, right? ঠিক আছে, গতিকে এইখিনি আমি ক্যালকুলেশন কৰিলে we will get something like 5600 divided by 1919, okay, 19.878 into 10 raised to the power something like minus 9 plus 34 minus 8. Ultimately this will yield us the number of photons, and that will be number of photons will be 280 into 10 to the power approximately equal to 280 into 10 to the power minus, sorry, 280 into 10 to the power 17. Yes, and this will be in the unit of per second. গতিকে 1 second this will be the amount of photons that will be generated by the 100-watt yellow bulb. This one, 100-watt yellow bulb discussed in the question. Take the same second question to go. We have done the first question. Now moving to the next question. The next question is electromagnetic radiation of wavelength 242 nanometer. 242 nanometer is sufficient to ionize sodium atom. এনেকুৱা question দিলে generally আমি ionize sodium atom, potassium atom, I don't know to we can confuse. No need to get confused. It is simply a question which we need to put in a formula, and we will get the resultant answer. Let's check the question. Sodium. This is not a complex question, but we simply get confused because here sodium atom, then sometimes potassium atom, not already. In order to do this question, we need to simply know this relation: E is equal to H nu, right? E is equal to H nu. So here GK question discuss so mostly all of them can be solved using this equation. This is a very fundamental equation, and you need to know this equation thoroughly. Even tough now. Simply E is equal to H nu, and where H is equal to Planck's constant, nu is the frequency unit whole hertz, or simply second inverse. Again, nu can be further divided by C by lambda. The C by lambda can go well. Speed of light can be related by C is equal to lambda is the wavelength and nu, right? It's me class 11 and 12 maybe that time is I issue, but again we will use this equation to solve questions like this. So let's start. Wavelength 242 nanometer. Again we will do the same trick, that is we will convert a nanometer into meter. But 240 nanometer means 242 into 10 to the power minus 9 meter, 10 raised to the power minus 9 meter. Okay, so this will be 2.42. again moving to the left into 10 to the power আমি কিমানটা position left ফালে 1 and 2, right? গতিকে minus 9 plus 2. Okay, 2.4 into 10 raised to the power minus 7 meter. Okay, now moving to this part of the question, calculate the ionization energy of the sodium. Okay, simply we will put this E is equal to 6.626 into 10 raised to the power minus 34 joule second. 34 my unit kita, let me specify the color, specify using the color. Let us have some color code, joule second. Okay, into 3 into 10 to the power 8, and here we will have meter per second, because this is the velocity of light, and this is divided by lambda. Lambda is simply the wavelength. So 2.4 into 10 raised to the power minus 7 meter. So this is the wavelength. So meter and meter can be cancelled out. In joule second we can cancel out joule, second and second. Okay, so joule will be the remaining unit, and that is what we need also ionization energy unit ki joule hobo. So unit is established. Now using the calculation, can chale 6.626 into 10 to the power minus 34 plus 8 to here পৰা আহিছে, and plus 7. Now plus 7 ক'ৰ পৰা আহিল? This is where it came from. Okay, and into 3 and this is further divided by 2.4. So this can be easily simplified. Let me simplify করলে 0.8. So the answer will be, you please do the calculation and comment, give us the answer in the comment section. Let us cross check whether it is correct or not, right? 0.028 into 10 raised to the power minus 17 joule. So this is the required answer of this question. This is also solved. Now moving to the next question. Okay, so here we have, find the energy of electron having de Broglie wavelength of 1 angstrom. It is very simple question. Sorry. Again, using the relation E is equal to h nu, E is equal to h nu यहाँ पे लिखा है. So we'll simply put the value of Planck's constant, that is 6.626 something, you know it very well, into c is the speed of light, 3 into 10 to the power 8. Okay, and that is divided by 1 angstrom. In this first slide we discussed what 1 angstrom is. There it is. 1 angstrom is equal to 10 raised to the power minus 10 meter. It is simply the unit of length. This is the CGS in meter. 10 raised to the minus 10 meter is the value of 1 angstrom. So ইয়াতে value কেইটা use কৰিম, that is divided by lambda. Lambda value আমাৰ দিয়া আছে 1 angstrom, that is 10 raised to the power minus 10 meter. So I believe you will be able to do it. Please do the calculation and comment us, give us the comment the value in the comment section. This should be near about 19. This should be near about something like, okay, let me put it near about 19 into 10 to the power 16 if I'm not wrong, 10 to the power minus 16 joule. Okay, so this is the answer to question number 4, this one. Now moving to the next question, and very important question, this one. Calculate the power radiated by 1 meter into 2 meter section of the surface of a hot body at 1000 Kelvin. So the black body radiation concept is, if you have gone through that concept, you have seen this relation, if I'm not wrong. R is equal to RB, that is emissive power RB is equal to sigma T raised to the power 4, right? So RB is equal to RB is nothing but the emissive power that is related to Stefan's, sigma is nothing but Stefan's constant, ST EF A and as Stefan's constant. T is nothing but the temperature, that is raised to the power 4. Okay, so RB is, let me write it, RB is equal to emissive power EMMISSIV emissive power. Okay, so if you have gone through this equation, I hope you can relate the question with this equation. Emissive power is equal to Stephan constant, that is multiplied by T to the power 4, that is temperature raised to the power 4. Okay, but again 1 meter into 2 meter section, what would this be? Simply আমাক দুটা length দিয়া আছে. Suppose this is 1 meter and this is 2 meter section of the surface of a hard body. Can you relate this? This is nothing but black body. Black body radiation gives us some equations like this: RB is equal to sigma to the power 4, and one more equation is there, lambda m, that is maximum lambda is multiplied by temperature, which again yields us this one 2.9 something into 10 to the power minus 10 raised to the power minus 3, and this one unit is meter Kelvin if I'm not wrong. Please cross check it. Okay, so we will work on this formula for this question. We don't need this one, so let me erase it. Please look at the question. 1 meter into 2 meter, this is nothing but an area, right? গতিকে Stephen's constant, that is sigma, আমি এইটোৰ পৰা উলিয়াব পাৰিম। গতিকে 1 into 2, that is 2 meter square. So this gives us area. The area of the surface, the area of this surface, which surface? This surface of the hot body. Okay, so the remaining question is, I believe, very easy. So let me put out the remaining question. RB is equal to 2 into temperature 1000 Kelvin. Had it been in degree Celsius, we would have converted it into Kelvin. The relation is, what is the relation between Kelvin and Celsius? That is K is equal to C. C means degree Celsius plus 273, right? So this is the relation. Anyway, we don't need this in this question. Let us focus. Okay, so temperature is 10 to the power 1000 Kelvin, means 10 to the power 3 Kelvin, right? So this is time is if power, or simply the power radiated by 1 into 2 meter section of the surface of the hot body at 1000 Kelvin. So the answer will be 2000, and the unit will be nothing but this one. So that's all for this video. I hope you liked the questions. These are very most probable questions, and out of these questions, the fifth question, this one is very, very important question. You please do revise this, check other numericals. So that's all for today. Thank you.